Hello and welcome. In this lecture, we shall discuss about the stack and the stack pointer in AVR CPUs. Before we discuss the stack pointer, let's understand what is the stack. Say you have a stack of books. The books are kept one above another. You can add another book on the top of the stack, and you can pick a book from the top of the stack only. Similarly, in computer science, stack is a way of arranging the data such that the data can be inserted and retrieved only from the top of the stack. You cannot retrieve nor insert the data in between the stack. The operation of adding the data on the stack is called push. In the push operation, the stack pointer is incremented by 1 and the data is added to the new top pointed by the stack pointer. The operation of retrieving data is called pop. During pop operation, the data is read from the top of the stack and the stack pointer is decremented by 1 to point to the new top. Then, what is the purpose of the stack? In the context of programming, stack stores the local variable of a function until the program execution is in the function. This is why the local variables are accessible until the program execution is in the function. It is also used to store the registers and return address before executing a subroutine or an interrupt service routine. An interrupt service routine is a special function that is executed when an interrupt occurs. The microcontroller uses stack pointer to keep track of the top of the stack. It has last in, first out data access mechanism and grows from higher to lower memory address. So, when the system is booted, the stack pointer is initialized to the highest address of the data memory, that is SRAM. Push and pop are two instructions used to insert and retrieve data from the stack. The push instruction decrements the stack pointer by 1 and stores the data on top of the stack. The pop instruction retrieves the data and increments the stack pointer by 1. The instructions call, icall, and rcall are used to push the return address on the stack and decrement the stack pointer by 2. RET and RETI instructions are used to pop the return address from the stack and increment the stack pointer by 2. Why is stack pointer decremented by 2 in call instruction and by 1 in case of push instruction? The return address is the address of the next instruction pointed by the program counter, which is 14-bit wide, and it needs two 8-bit memory for storage. Take due care to use correct instruction for stack operation if you are implementing program in assembly language. Note, in the earlier explanation, I have told the stack pointer is incremented in push operation and decremented in pop operation. But in the stack maintained for program, the stack grows downwards, that is from higher memory address towards lower memory address. So, in the later case, the push and the derivatives of call instruction decrement the stack pointer, and the derivatives of return instruction and pop instruction increment the stack pointer. The AVR stack pointer is implemented as two 8-bit registers SPH and SPL. The offset of SPH and SPL are 0x5e and 0x5d respectively. These addresses are used to access the stack pointer while using load and store instructions, and use the addresses 0x3e and 0x3d with in and out instructions. We shall discuss the addressing mechanism in subsequent lesson. ATmega 328 has 11-bit wide stack pointer. With this, we come to the end of this lesson. I hope it was interesting. Thank you.